Now, completing the square on that last example was well and good, but a lot of you may be thinking, well, that was the easy case. He had a 1 in front of this x squared, and that's all we really need in order to complete the square. But what do we do if a is not equal to 1? Well, we'll look at an example of how we might handle that. So if you remember anything from class, you might remember that in order to complete the square, the linear coefficient has to be 1. So since we don't have a 1 here in front of this, or I'm sorry, the quadratic coefficient has to be 1. But since we don't have a 1 in front of the quadratic term, then what are we going to do? Well, how about we factor it out? So I'm going to factor out a 2 here. And of course, 2 times what gives me x squared? Well, it must be x squared. Okay. Another way of thinking about that is that, well, there was a 2 in front of the x squared, and in order to figure out what goes there now, we can just divide. 2 divided by 2 is 1, which means that this is 1x squared. So then what goes in front of this x here? Right? 2 times what gives me 1x? Well, that would be 1/2. 2 times 1/2 gives me x. Again, you can think about that as dividing, okay, because initially there was a 1 in front of the x, okay, and 2 or 1 divided by 2 is actually 1/2. So I know that 2 times 1/2 gives me 1. And then what about this -6? 2 times what gives me -6? Well, that one's not so hard. I know it must be -3. And again, -6 divided by 2 is a -3. So we just factored out a 2 here. A little bit of labor to get this 1/2, but it's not so bad. At this point, we do exactly what we did last time. Now, this 2 is out here for safekeeping, but we're going to kind of ignore it for now. And when we need it, right, we'll use it again. So let's just focus on the part inside the parentheses. All right, these two terms right here. I'm going to write them down. I'll give myself a little bit of space. I'll write this -3 here. Okay, so just like last time, I have these this quadratic term and this linear term, and together they almost make a perfect square trinomial. I just need to figure out what to add in this blank space in order to make it a perfect square trinomial. And in order to do that, I do exactly what I did last time. I take 1/2 of the linear coefficient. That is, I need to take half of this number right here. So that is 1/2 times 1/2. And I take that and I square it. Okay, well, how do I multiply fractions? I multiply straight across. So numerator times numerator gives me 1. Denominator times denominator gives me 4. And I want to square that result. Okay, another issue. How do I square a fraction? Well, I square the numerator. So 1 squared is 1. And I square the denominator. 4 squared is 16. And there we have it. That's the number that we're going to add to these two terms to create a perfect square trinomial. So that means I need a plus 1/16. And remember what we said with the previous example. If I just add a number to this expression, I've actually changed my function a little bit. So then to balance things out, I'm going to also subtract 1/16 here. Okay, so we added 1/16 and we subtracted 1/16. We're just looking at these three terms here as a unit. And our goal is to factor them. And I know by design that it's going to be a perfect square. So I'm going to have something of the form x plus or minus something squared. So I need to think of a number such that when I square it, I get 1/16. And when I multiply it by 2, I get 1/2. Well, don't think too long. Remember what I told you in the last example. We can just look. All right. So what did we get before we squared? Well, we had a 1/4 there. So then that's the number that we're going to use. And in fact, you could check it. 1/4 times 1/4 is indeed 1/16. And 1/4 plus 1/4 is 2/4, which is 1/2. Okay. Now, all that's left for us to do is a little bit of arithmetic. We need to subtract negative 1/16 minus 3. I'll do that off on the left-hand side over here. Or better yet, how about the right? So, negative 1/16. I'm going to change that for now to plus a negative 3. Remember, in order to add fractions, we need a common denominator. So that 3, let's make it 3/1. And the lowest common denominator would be 16. So let's multiply by 16/16 right here. So then this becomes negative 1/16 plus negative 48/16. Which is then negative 49/16, because I'm going to add my numerators and I'll leave the denominator the same. So negative 1/16 minus 3 is negative 49/16. Okay, now let's not get too excited because we're not completely done yet, right? Remember this 2 here that we just ignored? So we need to carry that 2 down. That needs to be multiplied by 2, which means that this result here needs to be multiplied by 2. In order to multiply this expression by 2, we're going to distribute. But you want to be careful with that, because it's tempting to want to distribute this 2 through these parentheses. But remember, the order of operations says that exponents come before multiplication. So because of this exponent here, we can't distribute through that set of parentheses, and so then we're just going to write 2 times the quantity x plus 1/4 squared. Okay, and then here we're going to do 2 times 49/16, so that's minus 2 times 49/16. And we can quickly multiply this because remember, this 2 here is again 2/1, and 2/16 is the same as 1/8. So we're done. F of x is equal to 2 times x plus 1/4 quantity squared minus what's left, 49/8.